Welcome back. Having covered for loop, we can explain the repeat macro that we started using from the beginning. And in the process, we also want to explain some of the uh, sort of implications of the for loop to understand it better. So this is the repeat x, the macro definition that I'm using now. If I remember correctly, in topic 1, we were actually using slightly different one. At least in the video, we were using slightly different one. I changed the code later because this version is better than the one we use, and we are actually going to compare the two versions in a few minutes. So this uses a for loop, and the loop variable is RIJK. It should be a little bit unusual because oftentimes when people write for loop, they use either I or J or K. So you use int I equals 0, I less than n, blah, blah, blah. And here I try to use a variable name that is unlikely to be used elsewhere. So I guess actually I should make the variable name even more weird. So maybe I should have some underscore or number in between. So R9 underscore I1 or something. So the reason is if this variable name appear elsewhere, then it could be problematic. To see that, let's so I have a question. So which is actually let's this code, what will be the output? So we have a variable RIJK assigned to 3, and then we use the repeat macro, repeat 6 times, and each time we will do RIJK minus minus and x plus plus. So if this works as we originally intended, this is RIJK start with the 3. We're going to subtract it 6 times. We're going to get negative 3. And x should be getting 6, right? So x, we increment x 6 times. So now let's see whether this does what we want it to do. So we can use the online IDE again to try it out. So we don't actually need any input, so it's just run. Okay, so the output is 3, 3. So what this means is the loop is only executed 3 times instead of 6 times. And the reason is after we expand the macro, the code becomes this. So that repeat thing is replaced by this for int RIJK equals 6, RIJK greater than 0, minus minus RIJK, and then the body of the loop have RIJK minus minus x plus plus. So as you can see, RIJK is used twice here. So it's once it's declared here, and the other time is declared here. So this is allowed. So in C++, you can declare the same variable multiple times so long as they are in different scope. So here, the for loop creates a separate scope. So it's included in the scope for the main loop. And so in this scope, because we declared RIJK again, this will hide the outer declaration, meaning that inside the loop, all the RIJK refers to this new declared one. So I use blue to represent the inner declaration. So then if you look at this code, what it does is this RIJK subtract 1 is executed twice for every iteration. Once in the body, the other time in the condition. So again, this is also fine. So this is allowed. It's just that it may not be what a programmer intended to. Because of that, every iteration, RIJK actually is subtracted by 2. So that therefore, only by 3 times, the RIJK becomes 0. So then it will execute the loop. So that's why x will become only 3. At the same time, the RIJK in here refers to the outer RIJK. So all this going from 6 to 0 have no impact on the value of this RIJK. So this RIJK is still storing 3. So that's why we are seeing 3, 3 as the output in this code. So there is so this means that there is this concept of a scope of a variable. So when you declare a variable here, it will hide whatever variable you have outside. So I guess to begin, try to avoid having reusing the same variable name again and again. But if you oftentimes this hiding will be, you may have int I outside, you may also have int I in the loop. Then you think you may be updating the I outside, but you're actually not. So this will cause bug that if you didn't know, it will be really difficult to debug, because you're looking at, you're expecting one thing when the subtly the actual effect is different. So now let's see this code. What will be the output for this code? So I recommend you pause the video and think it through, or even try it out on the IDE. Okay, so now let's see what this does. So we'll repeat 6, and then we every time inside the loop we actually add to RIJK. So let's actually, I think it will be interesting to see how this will work on IDE. So we are running, and running. So we get a runtime error. So the status is a time limit exceeded, and the time limit is 5 seconds. So essentially we run for too long. We basically keep running and didn't stop. And this code, in fact, run into an infinite loop. So the reason is after expanding the macro, the code becomes something like this. So we use the repeat macro definition become here. So then, as you can see, inside the loop body, we add 1 to RIJK, and in the step statement, we subtract 1. So RIJK actually in each iteration, its value is not changed. So RIJK pretty much stays at 6. So it goes from 6, 7, 6, 7, 6, 7. So it just it's always greater than 0. So it's an infinite loop. So this kind of illustrates the danger of when we define a macro that you use a variable inside the macro. If it happens to have the same name as a variable elsewhere, it may cause trouble. So when we define this macro, we should really make this variable name pretty rare. I think RIJK is rare enough, at least for me. I'm not going to name a variable IJK normally. So well, you can choose a variable name that you feel rare enough for you. Okay, so that explains the using a name like RIJK. So there are two different versions of defining something repeat x time. So maybe the more natural one is something like this. You start from 0 and then you compare with x each time, and so that's one way to do it. And each time you add 1. And the other way is you start with x, and each time you subtract 1, and when it goes 0, you're done. So conceptually they're equivalent, but actually they can be different. So look at this following code and think about what will be the output for each of the version here. So what does it do? It repeat n, but there's a n. We actually subtract 1 from n in the loop body. So again, let's actually execute this code see what it does. So let's use first use this version. This start with x and then each time subtract 1. Run it. Okay, we get 0, 6, which is sort of with what we expected, right? N is 6. We repeat 6 times. Each time we will subtract 1, so then n will go from 6 to 0. At the same time, x goes from 0 to 6. So great. Now, what if we use the other version? So we replace this with that, with the going from 0 to x. Hey, we get 3, 3 again. So it looks like the loop is executed only 3 times. And the reason is when we expand the macro, when we expand the macro using this one, these we will be comparing with n every time. So we will start from 0. We'll be comparing with n every time in this repeat. But n at the same time is being changed. So the first time we are comparing 0 with 6. Yes, so 0 is less than 6, so we execute this. But then the next time when Rijk becomes 1, nx becomes 5 because we subtract 1 from n. So we're comparing 2 with 5, that's still less than. So we'll keep continue. And then we're comparing 3 and 4. And then the next time when Rijk becomes 4, n becomes 3. So then these no longer satisfy. We will exit the loop. So the loop is only executed 3 times. So the difference is when we use x here, this is executed only once during the lifetime of the loop because this is the initial statement. So this statement is executed only once. This condition is executed every time we execute. Every time, every iteration we execute it. So if we want to make sure when we do repeat n, we are really repeating whatever number of times this n at this, then we need to use this. Since that's normally what people should do, so we chose to use that. Of course, normally you shouldn't use the macro in this way, repeat n and then do n minus minus, but just in case you do that, at least the first version seems to be more what people would expect. So we are repeating this number of times. So whatever value this n take at this time, this is at the beginning, this is what we decide how many times it repeats. Otherwise, the behavior becomes fairly it can be fairly unexpected. So finally, just for your own to curiosity to figure out is think about what happens if we do this repeat. We use the second version, and then we do repeat n times n, and then we do this. So you can try out in the IDE. So we won't discuss it here.